Good morning. Today we have the question here for the question C6, which shows two children balanced on a seesaw. A seesaw is a length of wood which rotates about central pivot. So there are, as you can see in the schematic, there is two children, children A, where the force which is applied by the children A to the wood is 450, uh, where there's a pivot. Pivot is about 1.6 meter away from children A, child A, and 900 Newton is on the right side, which is 0 0.8 meters away from pivot for child B. So when it is, what does the question ask? The question asks that why does so the question says the child B moves 0.05 meter further away from pivot. So the child B is located here will move 0.05 meter away from here. So going to the right, 0.05 meter away. So if we were to imagine it, child B would move here. Same circumstances, same sort of force applying to the wood, but it would move a little bit farther. So it will move farther than pivot. So it would be 0.05 meter away. So the question says, what will happen? Explain why the seesaw rotates clockwise. It says why. Explain why seesaw rotates clockwise. Why seesaw rotates clockwise when child B moves to here. So we know that clockwise is going this way. If you could imagine if there was a clock here, if there was a clock here with the dials, it would move this way. So this is clockwise. So this is the dial and it's moving this way. So this is clockwise. This is anti-clockwise. The question already says when the child B moves to 0.05 meter farther away from the pivot, um, explain why the seesaw rotates clockwise. Why does it rotate this way? So we are going to solve this. To explain this, first we have to understand the concept of momentum. Why? What is momentum? Moments. What does moments mean? Concept of moment. What is moment? Moment is basically P equal to mv. What is mv? Or, in other words, the distance multiplied by moment is equal to distance from pivot multiplied by the distance multiplied by the force. So ignore this for a moment. Let me. Moment is calculated from distance multiplied by force. So how many meters it is? multiplied by force that's being applied. So we are going to calculate the moment here. The moment here. Therefore, if we are to calculate now, if we were to calculate initially before the child moves, let's do a scenario A. Scenario A1. So I'll just write scenario 1. When child B, I'll write child B, B's moment. It is child B's moment, 900 Newton multiplied by, this is 900 multiplied by 0.8 meter. I'll get 720 Newton meter. 720 Newton meter is when the child B is at his initial position or her initial position. While child A's moment is 450 Newton. So 450 Newton multiplied by this distance, 1.6 meter. Don't forget the units. 720 Newton meter. So we know that the force is being applied this way for child B. So it is clockwise. As I explained here, it's going to be clockwise. That's why you got to write clockwise. While here it is 450 multiplied by 1.6, 720. So when this moves this way, this goes up. So the movement is anti-clockwise. Can you imagine? This is because when it's moving this way, this is up. So anti-clockwise. So the rotation for child A is anti-clockwise, while for child B, that's clockwise. Hope you get that. And if you have questions, feel free to ask me on this one. I'm happy to explain further. So when you have this, you know that 720 Newton meter, 720 Newton meters, so it's a balanced scenario. When child is here, child B, and child A is here. So it's a balanced scenario. So both are, so there's no movement, right? So initially, so I can say that initially they are balanced. Initially balanced. However, child's new position, child B, child B's new position, where is it? Child B's new position is 700, sorry, child B's new position is 0.8 plus 0.8, which I get 0.8 meter, which is here, plus 0.05, this is the new, plus 0.05 meter, which will give me 0.85 meter. Big pivot. So we know from here, from when I'm drawing this one, my reference point is pivot. Right. So we agree until here. What happens is that now we have to calculate again the force, the moments to the new relative to the new position of child B and child A. So child B's moment what it is. It is The force hasn't changed. So that's 900 Newton, 900 Newton multiplied by the new distance. So the new distance here, if you are to draw it with a different color, this would be the new difference, 0.85. So multiply by 0.85 meter, which is equal to 765 Newton meter, which is clockwise. Again, because the force is applied this way, and again, the direction doesn't change, so it's clockwise. And again, we have to know why is it moving this like this. So we need to calculate child's B, child A's moment. What is it? There's no change for the location of child A. So hence 450 Newton multiplied by 1.6 meter is equal to 720 Newton meter. Again, it is anti-clockwise. Therefore, you can see that 765 is now greater than the child A's moment, which is 720. So 765 Newton meter is greater than 720 Newton meter. There, this is clockwise. I'm sorry, you can't see. So this is clockwise. This is anti-clockwise. So what's the direction? The direction is moving this way. The direction of rotation is clockwise, moving this way. Therefore, we have explained through the calculation, through these steps, that the seesaw is moving clockwise when the child B moves 0.05 meter away from pivot.